I'm CK. Today we have another Amazon or eBay find, I'm not sure which, a kit with the label all written in Chinese, but I see various interesting things in it. I'm not quite sure what it is. You probably know better than me because you saw the title screen. So we'll take it apart, we'll put it together, try it out, and hopefully we'll have fun with it. And I hope you enjoy the video. Let's see what we've got in the bag. Again, it's all Chinese, so I don't know what it says. It was packed in March 22nd, 2023. Let's take the paper out first because I think that it'll probably have a schematic. Well, it has a circuit board too. Good. Okay, it does not actually have a schematic, but it's got a parts list and location placements, because there's no QR code or URL for a build guide, so we'll just have to figure it out. I think it'll be okay. Let's see what this circuit board looks like. Where's my pointy thing? We've got caps, resistors and caps, and an LED and an LM386. I think that's an op amp, I believe, and a little transistor here. Looks like another LED here, another LED here, and an input. So obviously it takes some kind of probably sound, because we've got an audio cable, which is nice. Even if the kit doesn't work out, we've got a good cable. We've got a speaker. Now, speaker has, of course, attracted every piece of ferrous metal in this kit, which is actually good, because that means it's better than typical kit speaker. Usually we get those flimsy plastic junky ones, but this looks pretty good. 8 ohm, half a watt, nice composite frame and a fiber cone, so that's okay. That's better than average. And we've got two 9-volt battery snap caps. Let's dump the rest of this stuff out. Oh, it does have a schematic. It has a schematic on the back. They rarely have something on the back. So we've got input for, it looks like a stereo jack, which doesn't make any sense, but then we've got capacitor, a transistor, LED on the far side of the transistor, and then we've got D1. Where's D1? That's that diode. That's that diode there. Oh, okay, I see. This is actually a break-apart board. See the scoring down the center? I think I'll keep it together until we get all the parts on it. That looks like a timing crystal. So this takes the input, and the audio input is hitting the gate on the transistor, allowing current to flow out to D1, which is this connector. It's not a diode. Then we've got J1, which I assume connects to D2, and then that goes into resistor, capacitor, an LED, and there's the op amp, the 386 op amp, and some other capacitors and resistors, and then an LED going to ground, and then P1. Maybe it's an amp. I don't know. Well, here's something nice. 5 to 12 volts. So in English, they put the voltage. I appreciate that. We'll see. Last time I relied on what the voltage on the sheet was, we got magic smoke out of a voltage regulator. but this doesn't have a voltage regulator, so we'd probably burn up the transistor there. So it may be an amplifier. I'm going to make that assumption. So what I'm going to be probably doing... Oh, here's a little light sensor. Oh, I think I know what this is. I think this is a little... excuse me. I think this is a sound transmission using light kit. Now the only question is which one of these... This is a transmitter. I've seen these before. That's a little semi-laser diode in there. In fact, let me turn this on. Let me see if my LED buddy will fire this up. I thought I turned this off, but I guess I did. And there we go. 2.6 volts, 6 milliamps at 5 volts input, 390. Can you see that light up? There we go. See that? Off and on. So that transmits the light, and I believe this white one is not a, it's not an illuminated LED. This is the photoreceptor. These others, this is a regular diode, as you can see, just lights up. It's a red, so it's 1.9 volt because it's red or lower voltage than some other colors. And that's it. So we're going to take these two boards, populate everything, put the transmitter here, I believe. Then we have to power both these boards independently. And then we'll put the where's the sensing diode? That's what I don't understand. These are two regular LEDs. Unless this is the... No, that doesn't make any sense because you'd want the transmitter on the side that's got the audio jack, I assume. Maybe not. Well, we'll figure it out from the schematic. So I'll get the soldering iron heated up and we'll put this thing together. Oh, I'm back on because I just decided that I wanted to double check this. And as you can see, when I have this, when I'm not grounding it, when I have this facing my light, it's putting out 2.1 millivolts. When I cover it up, it's still picking up some light. When I cover it up, it drops down to 0.4. So that is the light sensor. Variable current based on how much light is impinging on the sensor. So that's what we'll be working with. Now I'll get the soldering iron heated up and we'll finish this, or we'll put this thing together. Okay, so to test while things are heating up, I went through to test our assumptions about where things are going. And let me get this, put my pins back in. I use old resistor leads to poke through circuit board holes so I can not get lost. If we look on this, the transmission side, we've got the input jack providing a variable signal to the gate, which is going to open current flow through here. And we know that the output diode, we've got the regular light diode, and then we've got the output diode at D2. And we know that because at the 100 ohm resistor right here is right here, and we flip the back of the board over, and we can see that feeds one side of the gate of the transistor, and the output of the transistor is going here through this diode and then here. So we're going to want to put our transmitter in these holes, and this diode will simply, this LED will simply show us the brightness. Now on the receptor side, if we look at what we're doing there, we've got this 620K resistor, which is right there, and then it's going to this diode right there, and then as you can see, one leg of the diode is connected to, where is it again? Trying to sort myself out. One leg of the diode goes along this trace, and then this and this are joined together by this cap, the 224 cap, right here, which feeds into pin 3, the non-inverting input of the of the op-amp. So we know that that's going to be our input, and then this is just a going straight to ground after this 1K resistor, just an indicator LED. So we're going to put our output here and our input here, and then there's power here, power there. So that's the way we're going to put this together. I think it'll work. We'll see, because that's the way it looks like it should work to me. Now I can't get my resistor pin back out of the hole, which would be bad. I always keep spare resistor leads in a little tray because I inevitably need them for something. But at this point, we'll go ahead and get some solder. I know I have some solder. That's thick solder. Where's thin solder? There it is. We'll do our typical progression of stuff. We'll start with our resistors. And what do we got? We've got 100 and a 1K. So we've got 4 resistors. We may have a spare. These kits often come with spares. And this 104 cap tried to escape. You're not going to fool me. So we've got a 51K, a 100K, a 1K, and a 620. So let's look for the 620 first. And of course, 6 has a blue band, and this is the only resistor with a leading blue band. So we know that's the 620K. And if you don't read resistor bands well, that's okay. Just go ahead and grab your meter, and we can look at that. And that's 0.639 mega ohms, which is 620K. I don't know why that went to mega ohm, but that's okay. Maybe because it was greater than 500K. So we know to put that one there. Again, I memorized resistor colors back in the 60s because that's all we had. I didn't have a meter. I actually didn't have a meter. I couldn't afford one because they were really expensive then. So you measured resistance band. Now this is brown, brown, black, black. So that's 1K. Put that there. Now we've got a green leading band, so that's a 5. Green is 5. And there's a 51K, so that's 5 brown, so that's 5, 1. And a 0 and 2 more zeros. Black band, red band. So that means 5, 1, 0, 0, 0. So that's 51,000. So 51K. Which leaves us with brown, black, black, black. So put that in 100. And the resistors are all sorted out. And what are we going to do next? We'll go ahead and put the decoupling caps on. Oops. I keep getting my head in the shot and I don't have my hat on. That overpowers the brightness on the cameras. This is a 103. Where does the 103 go? There it is. Providing a slight bit of decoupling to the input power, compensate for brief surges and so on, or ripples. Now we've got our 104 decouplers for the IC. Should have two of those, or is this a 224? This is another 104. There's the other 104. Now, got the 223. This should be a 223. I mean 224. Let's see. Oops, I keep trying to flip it and it won't flip. Yep, 224. Now I'll go ahead and solder these things we've already got on the board so they're out of the way. Now we'll put the IC socket on, and I could just solder the chip directly on, but I don't have a lot of spare 386s since I usually use some other op amps, but I'll use the socket so once I'm done with this kit I can harvest the op amp back out and put it in my spares cabinet. So that's that. Now I think I'm going to put the jack on for no other reason than I just feel like it, and that pin is bent. There are a bunch of little index points on here. You can see that pin's an index. There are two little pegs molded in on each side, actually, and then there's one in the center here. So it would be really hard to misplace this jack and have it sit flat on the board. And now we'll put our transistor on. And we'll put our various electrolytics on board. We got 300s, and the board is clearly marked as to where the positive long lead goes. And now at this point I'm going to break the boards in half, which is obviously easy to do. And I'm going to take my battery snap caps. I may not use them as with the 9 volt, even though I've got one of my rechargeables on the charger. I don't know where my other rechargeable 9 volt went. I have to buy another one. So we'll put power to things. And now we're going to put our P1 output here. Oops. Because this is going to go to P1 is coming from the output pin of the op amp, pin 5, and it's going through this cap, and P1 is going to be where we're going to plug in our speaker. Because we can see pin 5 is here, I think. No, that's pin 4. Pin 5 is here, and it's coming over here through that cap, that 104 cap, that 100 micro cap right here, and to the speaker output. Even though they don't explicitly call out speaker output, they just show it as output in general. Why are you doing that? These pins are not the easiest to bend by hand, so I'll bend them with some needle nose. This red indicator diode goes in here. Just to show that power is up. And then again, this diode through this cap to pin 3 of the op amp. I'm going to leave this up a little bit because I think I want to aim this. I think I want to aim that. In other words, I may want to bend that over. So I'm going to give myself some free play on the leads on the other side. I lost my solder again. I'll use this thick stuff that I have lying around. So I've got that a little up, but I can bend it if I want to aim it directly at the light in some way or other. There's my solder again. There's my 0.31. 0.031. Now I can trim that off. So that's that board done except for the op amp. We may as well put that in, and that is a little snaggly. Pins are. So needle nose pliers are really good for aligning pins, getting them all parallel with each other or in a line with each other. Bend them in a little bit. Make sure the notch faces the right way. Make sure we're going to get all the pins in their holes correctly. And I don't like that. I'm going to pull that back out. The pins got snaggly. They weren't aligned. That's better. Chips in. And one other thing I'm going to do is they gave us a little wire here to use for the speaker. Well, that's no good. That's not tightening down. Well, I'm going to, because it's not tightening down, I'm going to be like this, and I'm just going to, that screw post is apparently busted. So instead of connecting it to the screw post, I'll just solder it onto the back of the pins. Enough. Now in theory, I'm going to go ahead and do something just for fun. I'm like knock a bunch of stuff. Oh, my chip quick fell over. Don't want that. I'm going to plug the battery in on this side. And as you can hear, you heard it mumbling. So if you listen, I don't know if you're going to be able to hear this. I'm going to put the microphone right up. We've got light on the diode right now. And hopefully you could hear a hiss. Now listen while I cover the diode with my finger. I'm removing current flow and it's shutting off the op amp. So that's what's going to be happening. Let me clip this back on my vest. I hope you could hear that, but that's what's going to be happening when we set up the other half of this gizmo. So let me put that aside for the moment and do our final soldering of our diode. This diode. Red to positive. Get my locking tweezers. Oops, and it came out anyway, because I didn't actually have it locked. I used these little laser type diodes on a light organ. Interesting little kit that I did a year and a half ago or whatever. I'll try and remember to put a link in the description. It came out again. I'm not having a good time keeping this red wire in the place it's supposed to go. Use the last little nub of solder, because we don't waste solder on my channel because we use a lot of it. Okay, now trim these two leads. I'm going to get another battery and an audio source. Okay, I got a battery. I don't know where my other rechargeable is. It's somewhere in the shop. I don't know where it is. Oh, that powers up. And the lights seem to be doing the right thing. Got LED there as indicator, and we've got a little laser LED, which we'll talk to. I'm going to set the mic down right next to the speaker again, so when you can hear it when I pass the LED laser over the light sensing diode. So you can hear that. Now I've got a audio generator. I used the little stereo cable they gave us and plug that in like so. And I'm going to plug it into my iPad. We'll play one of my pieces, which sounds like this, Come on. Play. What is going on? There we go. So that's what it sounds like. I'm going to plug in the headphone jack. Now that's coming through there. Let's see if we get it transmitted. Oh, look at that. It works, my droogs and droogies. We've got a good strong audio signal coming in. And when we aim the laser, I have to get the right position. I'm going to turn the volume down here because it seems to be overpowering it. Now that's too low. Turn up some more output power, not less. Alignment is really important. See how far away we can go. I'm going to move this end of the thing. I'm going to detangle the signal generator and move this far away. Maybe 10 inches or so. Let me see if I can aim it. So there we go. We've got light transmission of an audio signal. All happened like magic. I'm going to turn this light off to see if that makes it any clearer. So there you go. Turning light back on. Works. A nice transmission of sound via light through the air. That's pretty neat, isn't it? So this is a very good kit, except obviously if you don't read Chinese, it might be a struggle to know exactly where some things go. I hope this helped. Again, the output laser goes in these two holes. The input sensing laser goes here to the right of these three electrolytic caps and above R2. So that's the light sensor goes in D2. So, and that's what I think you need to know. And again, it worked. Obviously not high fidelity, but I was hand-holding everything, and obviously if you were to mount it in a fixture and aim it just at the sweet spot, things would sound a lot better. But that's it. A pretty fun kit, and I think it was like $6 or something. And I'll put a link to the eBay page I bought it from. And I hope you enjoyed this video.